Bismillahirrahmanirrahim. Assalamu alaikum, students.
وعليكم السلام.
So before starting this lecture, I already sent you your midterm exam marks. I expect that you have received, and also the solution of the midterm exam. So last time we were studying this chapter number 7, and in this chapter number 7, we have some problems we have solved about the work done and the work kinetic energy theorem. So only we left the problems of this scalar product. So you should know that in the scalar product, so in scalar product, A dot B is equal to AB cos of theta. This is the formula. So in this problem, what you will do, you will find the A dot B is equal to AB cos of theta. The important thing is here the angle theta. So alpha angle is 30 degree. So you can find this angle because this angle is 180 and this angle will be 180 minus 30. So this angle will be 150. So A dot B is the scalar product and this is equal to A is 5 into 8 into cos of 150. Now you can solve this one and you can get the answer because cos 150 will be negative. So remember, after 90 degree, all cos angles will be negative between 90 and 180. So answer will be in minus 34.64. So this is the answer. So you can pick this one. Okay. After this, now you can see this is also the same like problem, but here you have to find the angle. So A value is 6 and B is 5 and alpha is 40 degree. So here what you will do, this is one vector A and this is another vector B. So we need the angle between A and B. So A and B angle mean what? A and B angle mean if this is A, this is B. So we have to connect this side. So what you will do, you will extend this line further like this one. Okay. So its tail will be here and head will be here. And this angle is given 40 degree and this angle is 180. So this angle will be 180 minus 40 is 140 degree. So angle between A and B is 140. But other things are simple. A dot B is equal to A is 6 and B is 5 into cos of 140. Now you can solve this one and again the answer will be in negative values. So this is 30 and this is cos of 140 and this is equal to minus 23. So minus 23 is the answer, not plus 23. It is minus 23 because cos 140 is minus. Okay. After this, if we have two vectors, suppose, this is just, I'm giving you one example. If we have two vectors, suppose A vector is 2i plus 3j and B vector is I plus j. I'm just giving you one example. And the question is, find the angle between A and B. So you apply the same law. A dot B is equal to AB cos of theta. And cos of theta will be what? A dot B divided by AB. So A dot B, first find A dot B. So A dot B will be 2 ones are 2 plus 3. This is equal to 5. So A dot B is 5. What is A? A is 4 plus 9. And this is 13 under root. And B will be 1 plus 1 under root, 2 under root. So cos of theta is equal to 5 divided by 13 under root multiplied by 2 under root. So you can solve it in the calculator, this one, and this is your angle. So if the question is like two vectors are given and you have to find the angle between the two vectors, what you will do? You will apply the same formula and solve it. So this is all about chapter number 7. Now I want to start this chapter number 8. So let's see the chapter number 8. So in chapter number 8, chapter number 7, first I want to discuss with you chapter number 7. In chapter number 7, what we have studied? We have studied about the work done. So in the work done, you have seen that work done is equal to change in kinetic energy. Mean the W is equal to delta K. So delta K is what? 1 over 2 mvf square minus 1 over 2 mvi square. So, and also this is called work energy theorem. Now in chapter number 8, we want to study the potential energy. So this is potential energy chapter. And we will find the change in potential energy. Find the change in potential energy. We cannot find the potential energy. We always find the change in potential energy. Even though you have studied this formula in your high school physics, that if a body is lifting and the body is here, we are writing here the potential energy is mgh if this is height h, because this is the final height and this is the initial height, and the initial height, the potential energy is 0. So that's why we write it mgh. But actually, this is the change in potential energy. This is not a potential energy. So remember this one. So in chapter number 8, we will study the falling objects. The bodies are falling, and find the potential energy and the kinetic energy. The body is lifting objects. Okay. And we will study about the pendulum height. Pendulum height means this one. If this is a pendulum, so the body pendulum is moving in this way, and how much is the height from this position? So it has potential energy. When it moves, it has kinetic energy. So we will discuss like this type of cases. And also we will discuss the spring mass system. Spring mass system. So in spring mass system, we will find the elastic potential energy. Okay. We will find the work done by frictional forces. This type of problems we will solve. And also we will discuss the situation in which we have an inclined plane like this one, and the ball is falling down. Surely it has some height. So it has potential energy, and when it is moving, this potential energy is converting into kinetic energy. Okay. Also, we will discuss the problems of the curve slide motion. Curve slide motion means like this one. Suppose the ball is moving down like this one and going up. So surely it has a height, and then it's parallel, it is in motion, and it is converting into kinetic energy and then again gaining potential energy. So we will discuss this type of problem. And also we will discuss uh, in the horizontal case, the spring is like this one and it is attached with the block and the force is applying in this way. And also the spring is like in the vertical position and block is falling on it and it is compressed by some distance x. So what will be the change in its elastic potential energy and what will be the kinetic energy? So these are the situations which we will discuss in this chapter. So I just summarize the situations. Now let's see. I'm starting this chapter number 8. So in chapter number 8, you will study first the concept of potential energy or change in potential energy with conservative forces. With conservative forces. Because we can find the change in potential energy only in conservative forces, not in non-conservative forces. One thing. The second thing we want to discuss and see the law of conservation of energy. Conservation of energy. We want to see like this one. Okay. So law of conservation of energy mean that potential energy plus the kinetic energy is equal to the total energy always remains constant, and this is called mechanical energy. So you should remember, I already explained you that conservation laws, we have only maybe we have one is the conservation of energy. 4 conservation laws exist in physics. One is the conservation of energy. The second is the conservation of mass. The third is the conservation of momentum. So these are the conservation laws. And the fourth one is the conservation of charge. So only 4 conservation laws exist in physics. But here we will discuss the conservation of energy, and in the next chapter we will discuss the conservation of momentum. So in this chapter, first I define the system. The system is a small portion of universe in which the particles are interacting. So due to that interaction, their energy is changing. So we want to discuss the potential energy. Okay. So, and this potential energy always can be measured for conservative forces. For conservative forces. So now the question is, what are the conservative and what are the non-conservative forces? First, I will discuss the conservative and the non-conservative forces. Then we will move towards this change in potential energy. Otherwise, you cannot understand this one. So, conservative forces. In conservative forces are those forces which are, if you want to find the work done, and that work done is independent of the path. Independent of the path. So independent of path mean that if you are moving from A to B and B to C, and then A to C, suppose the work done from A to B plus the work done from B to C is equal to work done from A to C, the force will be conservative. The second thing, if you have like this path, and this is the direct path, and this is the curved path, either you are you want to find the work done from A to B direct or from this curved path, If the value is same, the force will be conservative. Okay. The second thing we are seeing that work done in a closed path is 0. Then force will be conservative. So closed path mean what? This is closed path from A to B, B to C, and C to A. This is closed path. This is closed path. Body is moving up and coming down. Closed path. This is closed path. So remember, if we are taking A position and this is the B position, and body is moving from A to B, and similarly in this way, this is one path, this is two path, and this is suppose three path. If the work done 1 is equal to work done from 2 is equal to work done from 3, the force will be conservative. And the examples of the conservative forces are gravitational forces, and spring mass system forces, spring mass system forces. You mean the spring force. And electrostatic force, static force. This is also conservative. But in this chapter, we will discuss normally the gravitational force and the spring force. Okay, after this, now I want to tell you about the non-conservative. Now you can see the non-conservative force. Non-conservative force. So in non-conservative forces, the work done in a closed path is not 0. Work done is not independent of the path. It depends on the path. So you can see with this example, if we have this block and this is its A position and this is its B position, the force is, applied force is this one and the frictional force is this one. And the displacement is in this direction. And the force is in this direction. So the work done will be FD cos of 180 degree. If it is moved, because displacement is in this direction and frictional force is in this direction. So the answer will be minus F of D from A to B. Now we want to find the work done from B to A. Now you can see that this is A and this is B. It is moving in this way. So the direction of the displacement is this way. But the frictional force is in this way. Now you can see again the angle between them is 180 degree. So work done from B to A is equal to minus F of D. So the total work done in a closed path means one from this side and one from this side. So is not 0, it is equal to minus 2 F of D. So this is not equal to 0. So that's why the frictional force is called non-conservative force. Some other forces are also non-conservative. It is given in your book examples. So must read those examples. Which forces are conservative and which forces are non-conservative. So we discuss here the cases mostly in which the forces are conservative. Okay. Let's see the first article in this, the potential energy of a system. So in this article, what he wants to say, he is just telling us how you can find the work done by the conservative force. Okay, let's see. This is the earth and this is the book is placed at some height and this height is YA. And also you are lifting the book. Actually, in the first case, you are lifting the book, lifting a book. So you lift the book from this position to this position. This is your delta R. And here the position from the ground is YB. So what will be the this delta R. It is YB minus YA. Now, work done by the conservative force is equal to F applied dot delta R. So F applied will be how much? The weight of this object, and this is mg into J dot delta R, YB minus YA into J. So J dot J is equal to 1. So you can write this equation mg into YB minus YA. This is the external force we are applying. And this is equal to mg YB minus mg YA. So this is our equation. And this is equal to change in potential energy. And delta U is the change in potential energy. We represent here potential energy in terms of U. Now, in another case, we want to fall the book from this height to down. So what we will do? So the same situation, this is the ground and this is the book, and it is at YA, and here it is, and at this position it is YB. Now it is coming down. So with which force it will come down? It will come with this mg, its weight. So W on book is equal to this is the force, weight is the force dot delta R, and this is the delta R, distance between this position and this position. So here you can see it is moving down. So you can write this is minus mg into J dot delta R. Delta R is what? Delta R is YB minus YA. So you can solve this one, and minus mg, this is J, and J dot J is equal to 1. So mg YB minus YA. So here minus, and this is mg YB minus mg YA. And this is equal to minus delta U. So remember that change in potential energy is equal to minus work done by the conservative force. This is the formula you have to remember. So here you can see that work done is also equal to delta K. So delta U is equal to minus delta K. You can write like this one because this is work done. So delta U mean what? UF minus UI, final minus initial. Delta K, KF minus KI, final minus initial, kinetic energy. Delta K mean kinetic energy, change in kinetic energy. So you can write that this is KF plus KI, and this is UF minus UI. So you can rearrange this equation. This is UF plus KF is equal to UI, this is UI, plus KI. So this is called law of conservation of energy. And this is the mechanical energy. Now you can understand this problem in more clear way with this example. I'm giving you with a simple example. The simple example is this one. If a body is here at point A, then it is at point B, then it is at point C. C point is on the ground. This is on the ground. So the distance between A and B is X. This distance is X. And this distance is Y. This distance from here to here will be X plus Y. Now all things are clear. If any person is asking, what is the potential energy at point A? What you will say? You will say mgh. So mgh is what? From the ground is X plus Y. So total will be mgx plus mgy. What is the kinetic energy at point A? It is 0. Kinetic energy at point A is 0 because it is not moving, it is at rest. So the total energy will be what? 0 plus this. So this is mgx plus mgy. This is the total energy we can calculate at point P. So according to law of conservation of energy, this total energy always remains constant. Either you are at B or you are at C. Now I want to calculate at point B. This is at point A. Okay. Now if I want to calculate at point B, what I have to do? See, this is point, this is A position, and this is B position, and this is C position. This is the ground, and this is distance is Y from here, this position, and this is X. Now the body is moving from A to B. At point B, potential energy at point B will be equal to mg. From the ground, its distance is y. Potential kinetic energy at point B will be what? 1 over 2. Kinetic energy formula is this one. But we don't know from A to B what is the V value. Now we want to find the V value from A to B. So at point A, Vi value is 0. So it is moving down. We are taking A is equal to G, not minus G with gravity. And S distance is X. So apply the formula Vf square. So what will be the velocity at point B? Vf square minus Vi square is equal to 2Ax or 2Gx. So Vi is 0. So Vf is V. Suppose Vf is V. Then V square will be 2Gx. Now this is our V square value. Put this V square value here. Then kinetic energy at point B will be 1 over 2 m into 2Gx. So 2 will cancel with this one. Answer will be mgx. So what will be the total energy at point B? Potential plus kinetic. This is potential. So the total energy at point B is equal to mgx plus mgy. So it means the total energy remains the same as in the previous slide, mgx plus mgy. So this is at point B. Now, if you want to calculate at point C, you can calculate, the answer will be same. Now, let's see at point C. Okay, this is point A, this is point B, and this is point C. So this is Y, and this is X. Now at point C, potential energy at point C will be 0 because the height is 0. Now the kinetic energy at point C. Kinetic energy at point C is what? And we are writing here mv square. Now we want to find the V value from A to C. So Vi is equal to again 0, but now the distance is x plus y. X plus y is the distance. So apply the same equation, Vf square minus Vi square is equal to 2Gs. So Vf is V square minus this is 0 is equal to 2G into S. S is x plus y. This is your V square value. Now what will be the kinetic energy at point C? This is 1 over 2 m into 2G into x plus y. So this will cancel and answer will be mgx plus mgy. So the total energy at point C will be 0 plus this factor. So this factor is mgx plus mgy. So in this way, you can see that the total energy is always remains constant along the path. But this is constant in a conservative force, not in non-conservative force. So this is the total lecture today. So next time I will discuss with you the spring mass system and some more concepts about this one. And inshallah, next lecture, I try to finish this chapter number 8 because it has not more concepts. It has some formulas which you have to remember for that particular situation. So if you remember those formulas for that particular situation, you can solve the problems. So if you have any question, you can ask me.
Doctor, good morning.
Yes. Good morning.
I have a question, but not about this, not about the lecture.
Okay.
I have a question about the midterm.
Yes.
I was absent and I sent you an email because I was connected with two of my friends. They are infected by COVID-19, so that's the reason why I couldn't come to the exam. So can you please guide me? What should I do right now?
Yes, you can come in the university when you have this your lab.
Not the lab. I mean, the lab lecture.
Yes.
I think after tomorrow on Tuesday.
Okay, after tomorrow, so you can come and here this near my office there is one person. Its name is Saleh Al Anezi. Okay.
Okay.
So you can contact with him and he will guide you what you will do. Or you can contact with your course coordinator, Dr. Michel Al Harbi.
Michel Al Harbi or
yes.
who? Can you repeat his name, please?
Saleh Al Anezi.
Okay. Can I go to them today?
Yes, you can come. Yes. Yes.
Okay. Okay, doctor. Thank you. Appreciate it.
Okay, thank you.
Okay.
Okay, inshallah, see you in the next lecture. Assalamu alaikum.
Thank you, doctor. Appreciate it. Have a nice day.
Okay, thank you.